This is Math Essentials. Today we are doing notes from Chapter 4, Section 5 on slope-intercept form of a line. We're talking about slope-intercept form. This equation of the line defines the relationship between every x and y coordinate on a line in both directions in forever. It tells us that the y coordinate of that point is equal to the slope times the x coordinate of that line plus the y-intercept. Y equals mx plus b. So m is what we call the slope. That's how you get from one point to the next. Up 2 over 1 or down 3 and over 5. B is the y-intercept, and that's where the line crosses the y-axis. Y-intercept. Okay, parallel lines, when you're trying to find out if two lines are parallel, you look at their slope and they have the same slope, exactly the same slope. Now, on these next few examples, we're going to identify the slope and the y-intercept, but the first thing we need to do is make sure that y is by itself. So we'll solve for y if we need to. Number 1 says that y equals 3x minus 8, which means that the slope is 3. To get from one point to the next, you go up 3 and over 1. The y-intercept is at negative 8. That's where it crosses the y-axis. On number 2, the number we are multiplying the x by is 3, which tells us that the slope is 3, and that the y-intercept then is 5. That's where it crosses the y-axis. On number 3, the slope this time is going to be negative 9. We're going to go down 9 units and over 1 to get to the next point. And the y-intercept is at negative 2. Number 4 tells us that the slope is negative 1/2. That means you go down 1 point and over 2. And it crosses the y-axis at 7. That's the y-intercept. On number 5, we're going to have to solve for y first before we can find the slope and the y-intercept. So the first thing we're going to do is move the 12x's over by subtracting them from both sides. That tells us that 3 times the y-coordinate equals the negative 12x we moved over plus the 9 that was already there. Divide everything by 3, and y equals negative 4x. That means it has a slope of negative 4. Negative 12 divided by 3 is negative 4, and the y-intercept is 9 divided by 3. So the slope is negative 4. Y-intercept this time is 3. We're going to do much the same thing on number 6, in that we are going to solve for y first. Move the 6x's over by subtracting 6x. 4y equals the negative 6x that we moved over plus the 2 that's already there. Now we divide everything by 4. And negative 6 over 4 simplifies to negative 3/2 x. And the y-intercept, 2 divided by 4, simplifies to 1/2. So a slope of negative 3/2 means that you go down 3 and over 2 to find the next point. Last one, we need to solve for y. We're going to subtract 5x's from both sides. Negative 5y now equals the negative 5x that we moved over plus the 3 that was already there. So now we divide by negative 5, and the y-coordinate is negative 5 divided by negative 5 is positive 1. So that's going to be 1x, and 3 divided by negative 5 is going to be negative 3/5, which means that the slope this time is 1, and the y-intercept is negative 3/5. Okay, now we have several equations that are written in slope-intercept form, and we're going to graph them, which means to draw a line that goes through all of the points. First thing, we always start with the y-intercept. This time the y-intercept is -2. Crosses the y-axis right here. This tells us that we have a slope of 3. So the slope is 3, y-intercept is at -2. That means we go up 1, 2, 3, and over 1 to get the next point. 1, 2, 3, and over to get the next point. We only need 2 points to make a line, but if we have at least 3, that helps us with the accuracy of the point. And these arrows means that the line goes in both directions forever. Number 2 tells us that the slope is -1 and the y-intercept is at 3. Again, we start with the y-intercept at 3, which is right here. A slope of -1 means you go down 1 and over 1, down 1 and over 1, down 1 and over 1, as many times as we want. 3 is good, and go in both directions forever. This one tells us that the slope, which is the number we're multiplying x by, is 2/3, and that the y-intercept is -1. Start down at the y-intercept always, which is -1, and to find the next point, we go up 1, 2, and over 1, 2, 3. That's probably all that's going to fit on this particular graph this time, but we've got enough. We've got 2 points. Draw our line through that, and there's the graph of this equation. Number 4, we've got to solve for y first. So all we need to do for that is subtract the 2 x's here and the 2 x's there. So now y equals the -2x that we moved over plus the 2 that was already there, which means that this time the slope is -2 and the y-intercept is at +2. Go on the y-axis, find 2. There's the y-intercept. Go down 1, 2, and over 1. Down 1, 2, and over 1. There's our points. Connect the points, and there's the graph. Now this one's kind of interesting because we can see that the slope is -1/4, but there's not anything written over there, which means -1/4 is the slope. That the y-intercept, -1/4 x plus nothing, so that means the y-intercept is at 0. So we're going to start over here at 0 at the origin and go down 1 and over 1, 2, 3, 4. And there's our points. Connect the dots. And there's the equation of that, or the graph of that line. This is in standard form. We need to get it into slope-intercept form before we can graph it. So we're gonna move the 4 x's over here and here. -2y. It's a little fuzzy. There we go. -2y equals the -4x we've moved over plus the 8 that was already there. Divide everything by -2. Each term has to be divided by the same number. -2 divided by -2 tells us that y equals -4 divided by -2 is positive 2x minus 4. 8 divided by -2 is -4. So we start at -4, which is right down here on the y-axis. The slope is 2, so that means we go up 1, 2, and over 1. Up 1, 2, and over 1. There's our points. Connect the dots, and we're in good shape. Again, we've got to get y by itself, so we're going to add an x because this is minus. Add x there. 2y equals the x that we moved over plus the one that was already there. Again, the next thing we need to do is divide by 2. Y equals, this is 1x divided by 2, so that's 1/2 x plus 1/2, which means that the slope is 1/2, and the y-intercept also happens to be 1/2 this time. So, here we go. We're going to start at the y-intercept, which is 1/2, halfway between 0 and 1. If it has a slope of 1/2, that means we go up 1 unit and over 2. Up 1 unit and over 2. And there's the graph of the equation. Whoops. Let's see if we can make that a little bit more accurate. There, that looks better. Now, on this one, we're going to decide whether the equations are parallel. In order for them to be parallel, that means that the slopes are going to be equal. So we've got to put them in slope-intercept form, which means to put them solve for y. Minus 2x is here and 2x is here. Now, y on this one equals the negative 2x that we moved over plus the 5 that was already there, which tells us that the slope for this line is negative 2. This one already has it solved for y, but everything is flipped, so we're going to flip it around. We're going to say y equals the 2x, which is positive, minus 6, which is negative. So that means that the slope on this one is 2, and the y-intercept is negative 6. Because this has a slope of negative 2, and this has a slope of positive 2, they're not the same slope, so they are not parallel. Okay, again, we want to solve for y on this one. So we're going to add 3x's to get rid of it on this side and add 3x's. That tells us that y-coordinate is equal to the 3x that we moved over plus the 10 that was already there, which means that the slope on this one is 3, the y-intercept is 10. Now on this one, y equals 3x plus 4. The slope again is 3, and the y-intercept this time is 4. That means the slopes are the same. That means, yes, they are parallel. Okay, let's look at this one. This one's already in slope-intercept form. It tells us that the slope is 3/4, and the y-intercept is negative 1 this time. This one, however, has 4y, so we've got to divide each term by 4. 4 divided by 4 gives us 1y, 3/4 x, and 6 divided by 4, which simplifies to 3/2, which means that the slope on this time is 3/4, y-intercept is 3/2, and there we go. We got the same slope. So yes, it is parallel. They are parallel. My pencil. Okay, now this one just gives us a couple of points. So we've got to find the slope between those 2 points, and then we can compare the points and see if they are parallel. To find the slope, you subtract the y-coordinates, which in this case 5 minus 2 in the numerator, divided by 2 minus negative 2, the difference of the x-coordinates in the denominator. 5 minus 2 is 3 on top. 2 minus negative 2 is 4. When you subtract a negative, it becomes positive. That's the first one. The second one, we're going to say, again, subtract the y-coordinates in the numerator. 3 minus 0 and 2 minus 2 in the denominator. This gives us 3 in the numerator and 0 in the denominator. Anytime you have 0 in the denominator, that line is undefined. The slope of that is undefined, which means that the equation of that line is all of the x-coordinates are 2, as we can see. So this is 3/4, this is undefined. They are definitely not parallel. And that's it for the notes for today. Thank you for watching.